Hello everyone and welcome. My name is Caio. I am a journalist at 60 World and today I have the pleasure of talking to Peter Vetter, who is the president of Nokia Bell Labs Core Research. He has more than 30 years of contributions to the telecommunications industry and he's also the mind behind the 60 research at Nokia. So Peter, thank you so much for joining us today. I wanted to get started with this question. There's a feeling that the excitement for 6G has been cooling down a bit recently because of concerns about the monetization of 5G. If we cannot monetize 5G, how could we monetize 6G? So, do you think this is a good reason to slow down the development of 6G?
Uh, so I understand the concern about the monetization of 5G, but I actually think, on the contrary, 6G is an opportunity to re-architect the network so that we create more value out of the network. Let me explain that a bit more. Everybody agrees that AI and cloud are two important pillars of the future of digital economy, and there's actually a lot of money in AI and cloud. But the network is an essential third pillar. And we need to re-architecture the network in a way that we can better monetize and tap into that value chain and creating what we call application programming interfaces so that multiple parties, the application developers, different types of businesses can use the infrastructure as a platform so that we really move from the bit pipe thinking to more of platform thinking. And I think that is the way to go to better monetization of the 6G infrastructure.
Okay, now that we got past this problem, what are the technologies required for making 6G a reality? Why can't we just have more 5G, for instance?
Yeah, so every new generation is typically defined by a new technology, a new spectrum, new architecture, and then new capability. And in the case of 6G, I think everybody agrees that AI is the new technology, that we should redefine the network so that we can better leverage the benefits from AI. A very fast evolving field. So we really have a framework to benefit from the advantages in terms of network automation, but also in terms of better channel capacity. We've actually shown that with the first proof of concept that you can get to 30% battery capacity. So that is the new technology, and that in itself is a very important reason to rethink the network. The second one is new spectrum. So we've seen over the decades that approximately with every generation, with every decade, capacity goes up by an order of magnitude, by a factor of 10. Sometimes it's a bit slower, sometimes it goes a bit faster, but over the years, it's about a factor of 10. So by the end of the decade, the 5G network will run out of steam. We need new spectrum to allow for high capacity. And this is another reason why we should do this in a new way with the 6G technology, to design that in an energy efficient way. We cannot allow the energy consumption of the network to go up by the same 10x as the traffic. On the contrary, we pledged that we wanted power consumption go down by 50%. So then there's a new architecture. I already hinted at it in your first question. We want that architecture to really be able to be deployed as a platform. And the new architecture in 5G was cloud. Now let's go to cloud native design to exploit the flexibility and scalability of cloud to its fullest for the network, but then also have the open application programming interface so that multiple parties can benefit and so that we can monetize that 6G infrastructure in more efficient ways. And then the new capability, you can use the ubiquitous radios that will be all around us also as sensors. It's a kind of radar capability. It's not that we are reinventing the radar, but we can reuse the same base stations also as a sensor to detect movement of people, movement of cars, drones, and what have you. And there's a whole bunch of new applications that we then can think of in terms of traffic securities in urban areas, security or safety in factory floors, drone detection, and what have you.
I remember back in 2023 at the MWC Barcelona when we met there. Some of the technologies you just mentioned, they were already in progress. They were already being developed by Nokia. So these technologies you mentioned, what's the progress being made by Nokia in the development of them?
Yeah, so you remember very well, actually, already last year at Mobile World Congress, we have demonstrated a first AI air interface, really do an apples-to-apples comparison of capacity throughput, and we've shown that you can do 30% better than the existing digital signal processing technique. So that was one. And in the meantime, we made progress on that field also to make these solutions more energy efficient, and working with partners like NTT Docomo or SKT to test these concepts. And another one that we've shown at Mobile World Congress is also the joint communication and sensing. So the use case, that the new capability that I explained earlier on. In the meantime, we've been working with a partner, Bosch, to see and test that out in an experimental factory in Arena 2036 in Stuttgart, Germany, and really think of possible use cases and such. And then an additional thing that we have done is in collaboration with Qualcomm is also the interoperability of those AI concepts, because how do you enable interoperability between a base station and a handset or multiple handsets from multiple vendors with that new AI paradigm shift? And you don't want to share the AI models, because that is a bit the differentiation and secret sauce of different vendors. And we've shown that you can actually do it in collaboration with Qualcomm. So we made significant progress, very often in partnership with industry players.
That's fantastic. We have just talked about the progress, and I want to address the challenges. So when we talk about 6G, we're not talking about tomorrow. We're talking about 2030, 2031. What are the barriers that we have to overcome by 2030 to realize 6G, make 6G a reality?
Yeah, I think there's a number of challenges still ahead in order to be ready by 2030. As an industry, we have an agreement on a timeline that is 2028, 2029 to have the first specification in 3GPP ready. And we started interacting with our peers in the industry on that. So that is one important challenge. And for that, we also need to think of what are the day one capabilities that we really want to nail down for that first specification. Because there's lots of options and research concepts out there, but now we need to start getting serious. And one, it is that new spectrum, 7 to 8 gigahertz. World Radio Conference end of last year decided this is a important candidate spectrum, so we need to secure that spectrum and then also get ready with the system definition of that. Then two, it is make that platform ready for AI. And even though maybe some of these innovations are further out, at least have the framework ready so that the 6G network is ready for a decade to come on innovations, because AI is such a fast-moving field. Then the API readiness. So these application programming interfaces have the architecture ready for that. And then have also a smooth architectural evolution from 5G. Keep it simple. In 5G, we had this 7 options for an evolution from 4G. Let's keep it simple. One architecture option. And then also have the energy efficiency and the security in mind. So these are the day one capabilities that we want to have on security, especially also being ready for the quantum era and the post-quantum encryption.
Let me ask you a more personal question. So I'm pretty sure you've seen a lot throughout your career in terms of mobile technology and mobile communications. But personally, to you, What's next for you in the 6G research?
So in addition to these day one capabilities that I mentioned, I think we need to further mature the concepts. Within the framework of that day one specification, what are the innovations beyond day one? And then also making sure that we have the right system capabilities, like the items with the long lead time, the ASIC innovations. I'm actually standing here in an ASIC design and test lab. So really thinking also of new concept in that space, so that we continue to innovate on that. And then also at the network software and the network system level, there's lots to be done on the encryption side also. I mean, it's a cat and mouse game. There are new ways of hacking with quantum computing, with AI. How can we also make our systems more crypto agile?
Peter, before we get to the end of this interview, I wanted to ask you one more question. So you have attended several editions of the 6G Symposium, and we'll be having another one in September, on September 23rd and September 24th in Washington, D.C. And I wanted to ask you, what are your expectations for the next 6G Symposium? The topics you want to discuss, the discussions you want to hear, what are your expectations for it?
Yeah, so I like this every half a year cadence, and Europe, US, meeting people and exchanging visions on where we are going with 6G. Specifically on this one, I'm looking forward to engage on discussions, and that's also the panel that I'm on 6G use cases. And again, back to the question with which you opened it, how will we monetize that future 6G network?
Fantastic. Peter, thank you very much for your time. Thank you very much for this interview, and I'm looking forward to seeing you in person in DC.
Thanks, Kale. Also looking forward.
And if you want to hear more from Peter and other experts from the industry, make sure to go to 6gworld.com and register for the 6G Symposium, which will take place both in person and online. See you there.